Welcome to my island. Because I have this big inlet from the ocean on my island, I decided I wanted to build a boathouse over here. And then with a nice view of the bay, I built myself a big compound to live in, planted some gardens where I can get fresh fruit and vegetables to eat. Let me show you how you might go about building such a structure. First thing I do is I choose to make a building, and I think this time I want to build a little cabin. So I'm going to lay out a blueprint for it. Here's the footprint of my cabin. Let's make it just 1 story high, and I want red brick walls, and I'm ready to start building. Here is an initial inventory of bricks that I can use to start building, and the way you build is you have to fill, these rows are templates for building, and they also happen to be number lines. So you fill a row with exactly 3 bricks, and those 3 bricks have to completely fill the row. 3 bricks have to be exactly 2 units. Once you've filled a number of these rows, you can submit them to your building, and the bricks get laid out around your building. Let's see, I'm going to start with this 2/3 brick here. I'll drop it in, and that little animal that just dropped in a second brick is called a gruffin. So the gruffin's my assistant. So I choose the first brick, it gave me a second brick, and now I have to figure out what size brick I need to fill up the rest of that row. So first thing I have to do is add up these 2 fractions and see what's left. I have a tool that can help me do that called the Sketchpad. And so here I see these are fraction bars over a number line, and I need to figure out how am I going to add up these fractions to see what the sum is of the length. Now at this point I've already received some lessons in the need to find common denominators so you can add fractions together. And if I don't remember how to do that, I might explore a bit, taking these multiplicative identities and seeing what I get. If I do remember, I might go directly to the right answer. So I multiply this by 5/5, this by 3/3, and sure enough, you can see both visually with these lines and symbolically, seeing the fraction symbols, that I've come to a like denominator. 6/15 plus 10/15. So now let me add them up. And to do that, all I need to do is slide it over, and I get the sum right here. So notice the game determined that sum. My main work at this point was to figure out how to get a common denominator. So we do that intentionally in order to reduce working memory load and let the player at this point focus on that concept that we're trying to teach them. So now I need to figure out what size brick I need to fill up the rest of this row out of the bricks in my inventory. If I click on this box here with the sum, I can move between the mixed number and the improper fraction, and I get to choose which one I want to look at in order to do the mental arithmetic to figure out which brick will fill up my row. Now, this is a very fundamental design principle we have, which is for every type of transformation that you learn about, whether it's finding equivalent fractions, simplifying fractions, moving between mixed numbers and improper fractions, rather than just teaching a transformation, we want to give the player the opportunity to see why the transformation may or may not be useful at any time. So by clicking between these 2 versions, the player gets to decide which one do I want to look at, the improper fraction or the mixed number, to do this mental arithmetic. And so I see in this case it's a lot easier to do the mental arithmetic with the mixed number. So in other words, I've learned that this is a transformation that can help me in certain cases make my problem easier to solve. And that's why you do the various transformations that may be available at any time. So here I have 1 1/15. I need to get to 2. So I grab the 14/15 brick, and I've finished with that row. Now let's quickly do one more row. So here I'll grab a 5/6 brick, And I have a 2/6 brick, so in this case, the arithmetic's very easy. I put this together, and I'll finish this off with a 5/6 brick. And now I'm going to submit these 2 rows to my building. So I submit them, and here I have this spinner, little game of chance that will tell me if I get a bonus. Can I get twice as many bricks? This is a multiplier on the number of bricks that'll be added to my building at this moment. And in fact, I got a multiplier of 2, so I got a reward. I got twice as many bricks as rows that I had built, and I've partially built my building at this point. Now we have a very strategic reason for having that little game of chance just when you're submitting rows, because I just exercised this new concept, and that game of chance triggers the dopamine system right after I've exercised that new concept, so it helps with consolidation. It makes my learning of that concept more efficient. Now let's look at what the teacher's view of what's going on is. Imagine your classes in front of you, they're all building buildings, you've been working on teaching fraction addition, and we can see all the activity going on in the classroom. So across the top we see the list of conceptual leaps that students need to make as they master fraction addition, and for each student we see their status. If it's green, it means they've mastered that concept. Red means they're struggling with that concept. Yellow means they're working on and making progress with that concept. And blue means we don't have enough information yet on that concept for that student. Now, if we want more information about any particular student, we can click on that student and take a look. And for every game, we can see for that student how they're doing mastering every component concept, and within each concept their procedural fluency. So for example here, with easier denominators and with harder denominators, how are they progressing on mastering that concept? So using this, you can make decisions about how to optimize what you want to be doing at that moment with your class.